All right, this is AES, Advanced Encryption Standard. The presentation was made by Raymond Hache. If you ever enroll and you see a lady with blonde hair, that's his mother-in-law, so Elizabeth Sheehan. Raymond maybe still does for the NSA, I'm not positive. Really bright. He actually did this as a project for OSU, as like a capstone project, because he took, now if you search online, there's a little executable out there somewhere that you can walk through, which kind of show how AES works. But he made it into a nice PowerPoint presentation that's animated and actually works very well. So he gets all the credit for making this. Watch the prior recordings if you have any questions, because obviously I explain it a little bit different every semester. Does anyone ever watch the old recordings and stuff? Oh, yeah. Okay, because sometimes you might say stuff differently, especially when I skipped class like that one Tuesday and told you to go watch it. That was pretty handy. Okay, let's go through AES. It's the Richendale algorithm, okay? FIPS standard 197. Basically, they said DES sucks, okay? And so DES, a system breaking DES in 1 second, which can't be done, it doesn't break in 1 second, would take 149 trillion years to break 128-bit AES, which is the smallest key size. So does that sound like AES is a little bit better? Yeah, just a tad. Works good on both hardware and software, okay? Works on a wide range, has variable block size, variable key length, variable number of cycles. You'll be kind of walking through it one time, okay? You're not doing it, you're not varying the block size or anything, and you're working with the key I gave you. So, okay, it's very simple, low memory requirements, sound design. Works for pretty much everything, okay? Pretty much everything. All right. Details. This is most are Feistel structures. Some bits are basically swaps or transposed. Okay. It uses 3 different layers, which we're going to talk about. Okay. Uses what's called byte sub, shift rows, mixed columns, and add round key. Okay. You'll see we'll do some linear mixing. There's some parallel S boxes, some XORing. So nothing really new, with the exception of matrix multiplication, which is new. It's not hard, it's just tedious, okay? And normally, I tell you, if you're having problems with the matrix multiplication, write it out on hand on a piece of paper and bring it in and we'll walk through it. Because if you have problems, I'm going to do the same thing. Because, you know, that's the way you do it. I mean, it's, okay, so we're going to walk through it. It is resistant to all known attacks, okay, speed. Everything else works pretty much on everything. Strong math foundation, number of rounds, variable block, so as we said. So works good. All right. Now, hex values. So if I was to give you a letter, for instance, A converted to hex would be a 41. Y'all see that? Y'all see how to read this chart?
If it were an uppercase A.
Right. If it was a lowercase a, it would be 61. Okay. The assignment has a couple special characters depending on which version you end up getting. Some of them might use @ signs or exclamation points and stuff like that. Some of them didn't. Some have numbers, some of them don't. It's all random. Whichever I needed a phrase today. So it's a sunny day. It's a sunny day. There you go. That's a phrase. So that's where they came up with. So there were lots of thought went into them. So everybody okay on that? See how that works? All right. So let's see how dog works. So dog is D is 44. Everybody got that? Easy enough there. O, the small o, which is down there, would be 6F. You do top and then left. So this is that whole first question. It's ASCII to hex, okay? Or ASCII to state, I call it. It's the same thing, okay? So everybody okay on that? G would be 6, 7. So far, so good. Everybody okay on that? So could you do your name in this? Yeah, you should be able to. Okay. So Matthew, it would be 4D, so on and so forth. Okay, easy enough to do. Last year, they had to do their name. See, in the past, students all worked on that sample. I gave you with half of it blank, or actually more than half of it blank. But then the problem was one person would solve it and share it with everybody else. Not everybody, but a lot of people ended up getting it, and then when they went to the test, they were totally getting it wrong because they had no clue what to do. So then last year, I had everybody do their name. But can you imagine how much a pain in the butt that is to grade? Especially when it was 110 separate blocks I had to check. So what I would start with is I would take Austin's name, Austin Brook, type it in, and I'd go to the very end. If he's got the correct answer at the end, done. That didn't happen very often. So then I had to go back and figure out all 110 blocks, what he missed, and it would take forever. So now you saw what the new iteration of it is. So there's not that many choices. Some of you will be working on the same questions, but at least there is some randomness built into it. Okay. The cipher key, okay, is used to create a round key. Okay. I give you that. And you have to use it to create a round key. Okay. I just randomly picked that as well. Okay. So we're going to show how using this, so everybody's okay on this first part. How to take a phrase, dog, and convert it to hex. Easy enough to do. Okay. So here's our cipher key. I'm going to show you how to create a round key out of it. So we have our cipher key. Now we're going to create the round key. Okay. We take the last column of the cipher key. So we have 8A2261 in BE. Everybody see that? What did we do to it? Rotated it once. Okay? So basically the BA went to the bottom and everything else shifted up one. Everybody see that? Easy enough to do. I highly recommend, now I actually put the PowerPoint up there so you can walk through this. It's all animated as you can see. Okay? So easy enough. So we got that we took the last column, shifted it by 1. We're not nearly done. Shifted it by 1. Then we ran it through this S box. Okay? The only way you're going to find this S box is in this presentation. I didn't print out a copy for you or anything. Okay, but you can go to this page and print it, do whatever you want to do with it. So, we take the 22, gives us a 93, then the 93 goes up there. Okay? We take the 61, again, this starts, it even says first hex digit, second hex digit, so you really can't mess it up. You would have started from the top and the bottom, I know. Yeah, I probably need to do that on the other chart, put first and second, but, okay. So I tell you, Raymond just went through, if you search for Original, there's a little, actually it's a flash executable that walks through it, but it really doesn't explain it well. So you take an entire semester and come up with this, and it's like, wow, it actually works very well. So 61 would give us EF. That goes over there. Then BE. And that gives us AE. That goes over there. Then 8A. There's 8 and the A. 7E. That goes there. Okay. So now what we do is we take the first column of the cipher key. Remember we started with the cipher key. Plus this new row we just made. Where'd it come from? It came from the last row, shifted and then ran through the S box. Make sense? So we XOR those together along with this thing called RCON. Okay? Let's see how that works. So we take 37, convert it to binary. So we get 3 and a 7. So the 3 would be the 0011, and the 7 is the 0111. Now, I will tell you, you can do this entire thing in Excel. Because that's how Roy actually made, and if you listen to last year's recording, I explained it really well, but Roy made this for me. It was awesome for like one number. That's like, shit, it's always that way. So pretty much, but you can do it. I fixed it now. So if you look at my spreadsheet, it says created by Roy, fixed by Ken. So it actually does work. It has to be a newer version of Office to work. Okay, so we took the 37 and we took the 93. And remember we talked about XOR? One or the other, but not both. So what do we end up with? 1, 0, 1, 0. No. 0. The 2 zeros right here. These 2 zeros give us a 0. Then we get a 1, 0, 0. Okay? And magically, that's what we get. Okay? Is it already 6 o'clock? Wow. Okay. Then we XOR it with the RCON. Okay, now, you'll notice that really the only first one is the only thing that really has to be XORed with the RCON. You notice that? Because if you XOR it with zeros, it really doesn't affect anything. So all that's going to affect is the last bit. All right, then we convert it back. So you see how we converted that back? The first 4, 1, 0, 1, 0 is an A, then 0, 1, 0, 1 is a 5, and that goes all the way up into the top. Everybody got that? Yay, then you do the same thing for 89, EF, then you end up with 66, and 91, and 12. All right, so all that, come on, all that becomes the first column in our round key. Isn't that a lot of work? So is there anything tough about that?
On that last part, where
Yeah.
you have like the 0, 1, so if it's 0 and a 1, it's going to be a 1. If it's 2 zeros, it'll be 0. If it's 2 ones, it'll be a 0.
Correct. One or the other, but not both. 1 and 0 is a 1, 0 and a 1 is a 1, everything else is 0. One or the other, but not both. Good question. Yeah, because if you screw that up, I mean, you're dead. All right? So that gives us the first column. So remember, we took the last column of our cipher key, shifted it, ran it through the S box, XORed it with the first column and the RCON to get the first column. Have we got that? Please walk through the exercise. Walk through the worksheet. I mean, I can give you a blank one if you want, so you can walk through and fill it in. And then, if you can't figure out how I'm getting the answer, please ask me.
Wholeheartedly give us a blank one to work with.
Okay. Yeah, I can do it. I can actually send you the worksheet if you want in Word, then you can just erase the numbers. Okay. All right, so that's our first column. Okay? Now, to get the second column, see, the first column's the only one that's a little tough. Second column, we bring down the second column there, bring down the first column that we just made, XOR those together. Okay, that goes back up. See, isn't that much easier? But we bring in the third column, XOR it. Remember, that was the second column, so this one's going to end up being the third column. And we bring down the fourth column, XOR it, and that goes into the third column, and this one becomes the fourth column. Everybody okay on the creating a round key? Easy enough?
Not too bad.
It's not hard math, it's just a lot of steps. Just walk through it, okay? All right, so there we have our round key. Yay! Okay. So we need to take our state. That's that first thing. Remember, we took our phrase, ran it through our ASCII chart, and got our state. And we take our cipher key, and we get a new state. We can see how this works. Okay? You XOR these together. Okay? And that does work. And we're going to show you how right now. Okay. Yeah. You take, hold on, make sure I'm on the right one. B and 37, yeah. You take this one here, run it through this chart, and you get that one there. The B2, I know this one doesn't light up down here, but you know, you got the B2, like, so B would be right there. 2 is right there, gives us 37. You see that? Okay, let me go back one. Okay, this part we XORed, so you XORed 85 and 37, you got B2. 1D, 89, you got 9, it's just straight across. Okay, nothing special on this one. Everybody okay with that? That's how we get our new state. Okay, but just do exactly like I show you on the worksheet. It's very simple. Okay, so it's straightforward. Everybody okay on this step? Just run it through here. Okay, and this becomes, hold on, get the number it becomes. All right. Let me get the number it becomes. Hold on. Let me go through this real quick. Hold on. Okay, that was the states aren't labeled too well in here. Let me bring up the other sheet. Yeah, because I thought they were labeled better on there, and they're not. I need that worksheet. Okay, I'm going to bring up that worksheet right here. So you can see the steps I'm talking about. Okay, so we took this here. We took this phrase, computer-eyed 1357, went through here and got this. Are we okay with that? Yes? I give you the cipher key. Then you take the cipher key and create the round key by, remember, we rotate this last column, run it through that S box, RCON, XOR it all together, get the round key. Okay? Then we take this state right here, this 436F, is this state right here. See that right here? This is called state. So this is the same state. So you XOR it with the cipher key, and that is right where we're at, right here. And that gives the new state, which in my worksheet is state 1. Okay? Then you take state 1 and get that, and that is, let me go back to my worksheet again. Okay, so that gives you this. Okay, that's state 1. Then one with little arrows in the chart, you take state 1, run it through that S box. So that is, this is state 1 becomes state 2. Following me?
That's the S box.
The S box, yeah. This is the S box. Substitution box. But you all following the steps I'm talking about? So state 1 goes through the S box, becomes state 2. So this is state 1, goes through the S box and becomes state. I probably need to put the title underneath. It'll be easier to remember that. But everybody okay with that? Everybody follow me so far? Okay? So we ran that through there, and we get that. Then, now we're back to, so now we have our state 2. Then state 2 becomes state 3 by shifting rows. So I tell you exactly what you do to each one. So how do we shift rows? Okay. So row 1, no shift. Row 2, we shift by 1. Remember, 22 is at the beginning. 22 is now at the end. So we rotated it basically. So this next one, we shift it by 2. So 3F will end up being at the beginning. See that? This last one, which one will be at the beginning? Should be 6C because we can shift by 3. So the AF goes around, then the next one, and then the next one. Okay? So that's 6C. So that ends up becoming state 3. Okay with that? Everybody following along here? Those are all very simple. I mean, seriously, how can you possibly screw that state 3 up? Okay, Matthew, possibly. But no, I'm just kidding. No. Okay, so how do we get from state 3 to state 4? This is the one that's the toughie. Okay? So we got state 3. Now we need to go through what's called mixed columns. Matrix multiplication, basically. All right, we take the first column times the top row just to get one square. That was that AA, that top left block. Okay? Then you do the second row, third row, and fourth row, and so on. And we're going to see how all those fit in. That's why I made that worksheet for you. Actually, let me bring up that worksheet real quick. I made these because so many people had questions about it. That's this one. So, A and 1, B and 2, C and 3, D and 4 just gives us AA. Will it make a little more sense now?
Where's the AA come from?
I just put the AA right there. I just needed a way to identify the cells. And I figured AA was just an easy way to identify them. So you take whatever the value is here, this A, and in this case would be the 37. Okay? So you take the 37 and whatever is in position 1, which is O2. So you take the 37 and O2. And 37 and O2, multiply them together, which we're going to see how to do. Then you take the 49 and the, which one's 2? That's the next one, what's going across. So take the 49 and the 3, multiply them together. Then you take the 3F and the 1, and then the 6C and the 1. You XOR all those together. Okay? All that becomes this top left block right here, this AA. Can't mark it, but this block right here. So all that work just gave you AA. Okay? And to get BB, it's A times 5, B times 6, C times 7, D times 8. All XOR together. That gives you the B. So what we're doing is we're taking this first column times the top row to get the top value over here, top left value. Then the first column times the second row to get the second one down. First column, third row to get the third one down. First column, fourth row to get the fourth one down. Then we take the we do it all over again. Second column, top row to get the second column, top one. Second column, second row gives us the second column, second row, so forth. Make sense? Follow that worksheet. I walk you through exactly how to get each letter. I couldn't think of any other way to identify, so I just did A, A, B, B, C, C, D, D, and it seems to work. Okay? So how does all this work? I'm thinking pretty much all of you are lost at the moment. Pretty much? Okay, that's good. Okay? Then we do that. Then we do the third column. Then the fourth column. All right. Look familiar to anybody? Well, actually, this is algebra. Okay. There's 8 bits. So remember a couple slides back, we were showing how we could convert the numbers to binary? Remember that? Well, you need that again. So we're going to take that first column, which was 37. We're going to start with that one. And we're going to multiply by 2, then 49 by 3, 3F by 1, and 6C by 1. Okay? So how do we do this? Well, how do you multiply 37 times 2? Let's see how to do that. So we're going to do 37 times 2, 49 times 3, 3F times 1, and 6C times 1. And what does all that give me when they're XORed together? The first top left, which is that AA block. One person's here. I like that. No. This is a look of it. We're going to walk through it. Okay, so how do I do 37 times 2? Let's see how to do that. First of all, we take the 37, convert it to binary. We've done that already. Okay, easy enough there. Okay. Take 37, and we take the 2. Well, we need to multiply them. And what you do, so 37 is 8 bits. Do you realize that? There's 8 bits here. Even though some of them are zeros, they're still 8 bits. Put them underneath here. So 37 would be 0, 0, x to the 5th, x to the 4th, 0, x squared, x, and 1. You see that? So 37, we have 0x to the 7s, 0x to the 6s, we have 1x to the 5th, 1x to the 4th, 0x to the 3rd, 1x squared, 1x, and 1, 1. So that's why 37 is x to the 5th plus x to the 4th plus x squared plus x plus 1.
So basically, when you line it up, all your ones is what you're multiplying.
Exactly. Only work with the ones with the 1. So if you make a little chart with this going across the top, just put your numbers underneath it. And the ones that have 1s you work with. The rest of them you skip. So that's 37. Now we do the same thing with 2. So what's 2 going to be? Which would be?
X.
Just x. So 2 would just be x. Do y'all see how we got just x? Okay. So now we need to multiply x to the 5th, x to the 4th, x squared plus x plus 1 by X. They want to remember from algebra. This is the only part of algebra we actually use in this class. All right, see how that works. You multiply them out. So x to the 5th times x becomes x to the 6th. X to the 4th becomes x to the 5th. X squared becomes x to the 3rd. X becomes x squared. And x times 1 is obviously x. So you see that? See how we got that? Then take that, shove it back up underneath that again. So what are we going to get? We're going to get, how many x to the 7s do we have? 0. How many x to the 6s? 1. So we got 0, 1, 1, 0, 1, 1, no, 1, and then 0. Okay? So we put that back up there, and we get 6e. So, 37 times 2 is 6e. Got that? It's not hard. That's actually not difficult at all. It's just that it's going to get difficult in a second. Well, not difficult, but it gets a little confusing. It's just going to take some time. That's why you need to write all this out. So when you have questions, I think I helped someone last semester. I wrote it all out on paper. I took a PDF of each page and said, okay, sure you messed up, but here's what you should have had. So, okay. So everybody okay on 37 times 2? Easy enough. Okay. That gave us 6e. All right. The next one was 49 times 3. Let's see how that one works. So remember, there was 0x to the 7th. There was an x to the 6th. No x to the 5th. No x to the 4th. But we have an x to the 3rd. We have no x squared. No x's. But we have a 1. Okay. Now we got something a little bit tougher. Because now we have an x and a 1. So what happens when we take 6x plus x, x to the 6th plus x to the 3rd plus 1 times x. You can do that already. What does that become? So what is x to the 6th, x to the 3rd plus 1 times x? X to the 7th. So it's x to the 7th, x to the 4th, and x plus x to the 6th, x to the 3rd, and 1. Because we still got to multiply it all times 1. Because remember, there's a 1 there. We did the x. Now we need to do a 1. And the 1 is just each number again. So when you multiply it out, so x times that becomes each one raised up by 1. Okay? 1 times that becomes themselves. So you end up with x to the 7th, x to the 6th, x to the 4th, x to the 3rd, and 1. You can move them around. I mean, that's not a problem. Everybody see that? Okay. Put them in order. And we get dB. So far so good? A little bit tougher, not a lot. You just have to remember you have to multiply by x and then multiply times 1. And any number times 1 is itself. That's the way it works. All right. So 3f, remember that's what we got, 3f times 1. There's that. And what is any number times 1? Itself. So what is 3f times 1? 3f. So you really don't have to do anything with that one. Easy enough? So if you just happen to have one with all 1s, which you don't, but if you did, it would be awesome. It would just be itself. It's never that easy. Okay. Okay? All right. So, 6c times 1. Same again. All right. So now we have all those. Now we need to take them and XOR them together. Come on. So we did all those. We just did that. Are we okay with that? Remember, the last two, we really didn't, the 3F and the 6C, we didn't have to do anything with them. Okay. So we ended up with 6E, DB, 3F, and 6C. So far, so good? And all that gave us that top left block. Remember that. So we took each of those numbers, became E6, and you know how to XOR them. You really didn't have to convert them back to hex because you needed them in binary anyway. But, But that's how you got E6. So all that work for one block. Okay. I'm going to tell you right now the problem you're going to have. You're not going to walk through the example, and you're just going to go jump right on your homework and you get all these wrong. I'm just telling you. Because there's some tricky parts to this, which we're going to see right now. All right. I wrote a Java program that does everything up to this very next part, and I just never finished it. So there's something called the Glois field. We're going to see when we might want that. Okay. Pretend we have E7 times 3. E7 is x to the 7th, x to the 6th, to the 5th, x squared, x and 1. Okay? Nothing new there. And we have 3. So what is E7 times x? Would be x to the 8th, but wait a minute. Our thing didn't go up to 8, did it? Because if there's only 8 bits, x to the 7th is the size we can go. So what do we do? Well, here's how we fix it. So x to the 7th and all that times x becomes x to the 8th, come on, plus x to the 7th plus x to the 6th, third squared, and x, plus those numbers all over again. Okay? So that's a lot of numbers. So what the heck do we do? Well, it's easy. First thing to do is cross out the duplicates. Every number twice, get rid of it. So we're left with x to the 8th, x to the 5th, x to the 3rd, and 1. But still, we got a problem, because remember that first chart I gave you didn't handle x to the 8th. So how do we fix this? Well, we XOR it with the Glois field, which is right there on the top of the screen. So if you have x to the 8th in your answer, XOR with the Glois field. And since we know that XOR 1 and a 1 means 0, and if your answer has x to the 8th and the Glois field have x to the 8th, guess what happens to the x to the 8th? It goes away. There you go, and you XOR those together, and it drops off. And you end up with, what do you end up with? Where did my mouse go? So 5, x to the 5th, x to the 4th, and x. See that? All right. Now, one thing I didn't tell you. Let me back up here a little bit. I'm just going to back up to this one. Yeah, this will work. Okay. So I backed up to this stage. I'm going to bring up handy dandy calculator. Now this is going to get you in trouble. I'm going to tell you right now. But I'm going to show you anyway. Because if not, you're going to do it. And okay. So if I want to take 49, I got it on hex view here. So 49 times 0.3. What's the answer I want? Should be dB. Isn't that awesome? So let's check out 3f times 0.1, 3f. Actually, we needed one before that, didn't we? Let me go back one more. But didn't we have one more before this? That one. So let's do that one. Let's make sure it works. Okay. So this was 37 times 0.2, 6e. Perfect, isn't it? So you guys like, sweet, my homework's done. Okay. Let's just check this baby out. Yeah, I got to get like 12 slides away here. One bad thing about animations. Okay. So now let's try this handy dandy little calculator. E7 times 0.3. What should I get? 2b5. So it doesn't always work. It doesn't work when there's an x to the 8th involved.
So I suppose this is how I tell the calculator lets us know we have to do the Glois
Right, and then you could actually, I think, because what you could do at this point, you could actually XOR it with the Gloy's field, and I think it'll actually give the correct value. But you'll have to figure that part out on your own.
So it's safe to use it unless it looks like that.
Yes.
Because there's an XOR button on there to use.
Yeah, there is, but you'll have to, okay, what is, okay, x to the 8th. See, the problem is, remember we had 2 digits? Now we got 3 digits. That's an issue. We can't just chop off the 2. Okay, so it gives you some food for thought, but just remember, it's not going to work on all of them. So I would use it to check my work for sure. But if you have it, okay, if you have anything with a 3 in it, that's where the problem comes in. And it's really the 3 multiplied by a certain larger number. And E, believe it or not, is a very large number, because it's 0, 1 through 9, then A, B, C, D, E, F. So really, it's the 3 in combination with a high hexadecimal value that causes this. Okay? So I'm warning you, don't always rely on the calculator because you're going to get it wrong. Okay? But yes, you can XOR it with the Gloy's field and it will give you the correct value because that's the way we did in our spreadsheet. Okay? Everybody got that? Did I state that well enough? Okay. So yes, you can use a calculator for almost all of this. But you just need to know how to do it. Because don't tell me 2B5. That's wrong. All right. So where are we at now? I think we're on the last one, aren't we? This should be, let me go back to my worksheet here. Where's the practice again? Yeah, I do need to label those a little bit. That might make it a little bit easier. So I don't think they were labeled on here originally. So we did all that. Yeah, so now we're taking the one we just made, state 4, with our round key to come up with our ciphertext. So we're taking our state 4 on the left with our round key and come up with our ciphertext. And all that is our, and again, this is just straightforward. You can literally E6, XOR A5, and you calculate and get the answer. Okay? But you know on the test, something's not going to work with the calculator. Of course. Okay. That's pretty much it. Yep. After mixed columns, round key gives us our ciphertext. And then you're done. Now that is just round 1 of AES. And remember, the key is variable length. The block, in this one we're using 16 bits, or 16, so 16 times 8, so it's pretty large. But the amount of carriages can do, the block size is variable, the rounds is variable, the key is variable, heck, everything's variable. Which is kind of nice. All right, I think that's it. All right, are we okay with that? Easy enough to do? You all like that very last thing I showed you, didn't you? You're like, sweet. But make sure you know how to do it because the calculator won't always do it. All right, that's the end of AES.